Lowe's knows you want to get even more value for the holiday. That's why as a My Lowe's Rewards member, you get new member deals on holiday decor, tools, and more. And you earn points when you shop. More points equal more rewards to help you save on holiday and more. Not a member? Join for free today at Lowe's.com/MyLowe'sRewards because Lowe's knows deals. Program subject to terms and conditions. Points are awarded on eligible purchases. See Lowe's.com/terms for full details. Subject to change.
Are you tired of feeling vulnerable online, spied upon, censored? Protect your digital life with NordVPN, the cybersecurity solution that keeps you safe in your own online bubble. With NordVPN, you can browse, stream, and work worry-free, knowing your data is secure from prying eyes. Imagine having access to over 6,400 ultra-fast servers in 111 countries, ensuring a stable connection wherever you go. NordVPN offers uninterrupted streaming, easy setup, and cutting-edge encryption. But that's not all. NordVPN goes beyond basic protection with features like malware scanning, ad blocking, and a strict no-log policy. Plus, you can secure up to 10 devices with just one account. Don't compromise on your online security. Visit bytes.com/NordVPN now to grab our special deal and enjoy up to 74% off plus 3 extra months. Plus, there's a money-back guarantee. Link is in the show notes and on our website. Take control of your digital life today with NordVPN. The link again, bytes.com/NordVPN.
Welcome to Astronomy Daily. I'm Anna, and we have an absolutely fascinating lineup of space discoveries and astronomical events to share with you today. From groundbreaking research that's challenging Einstein's fundamental theories about the universe, to new insights about how space travel affects human aging, the world of space science continues to amaze and surprise us. We'll also explore some spectacular cosmic events, including a brilliant fireball that lit up the North American skies and an extraordinary experiment where NASA created artificial clouds beneath the glowing auroras of Norway. Plus, we'll look at the latest developments in satellite servicing technology and get an update on NASA's ambitious Tracers mission. Stay with me as we journey through these extraordinary stories that are expanding our understanding of the cosmos and our place within it. Our first story today challenges one of the most fundamental theories in physics. Scientists from the universities of Geneva and Toulouse have been analyzing data from the Dark Energy Survey, and what they've found might make Einstein himself raise an eyebrow. They've been testing how gravity bends space and time across different periods of the universe's history, and the results aren't quite matching what Einstein's equations predicted. Think of the universe like a giant flexible sheet that gets bent and curved by massive objects. That's how Einstein describes space-time. When light travels through these curved areas, it bends, similar to how a glass lens bends light. Scientists call this gravitational lensing, and it's been one of the cornerstones of our understanding of how the universe works. The research team looked at an incredible 100 million galaxies at different points in cosmic history, ranging from 3.5 to 7 billion years ago. Here's where it gets interesting. When they looked at the distant past, around 6 to 7 billion years ago, everything lined up perfectly with Einstein's predictions. But as they looked at more recent times, about 3.5 to 5 billion years ago, they noticed something odd. The gravitational effects were slightly weaker than Einstein's theory suggested they should be. What makes this particularly intriguing is that this period coincides with when the universe's expansion started accelerating, something we still don't fully understand. Could these two mysteries be connected? The researchers think we might need to consider the possibility that gravity works differently at very large scales than Einstein's equations predict. Now, before we declare Einstein's theory invalid, it's important to note that the difference they found isn't quite strong enough to completely overturn his work. The scientists are calling it a 3 sigma difference, interesting enough to warrant further investigation, but not yet at the 5 sigma threshold that would signal a definitive discovery. They're now looking forward to analyzing new data from the Euclid Space Telescope, which should provide even more precise measurements to help solve this cosmic puzzle. The mysteries of space travel continue to reveal new challenges for human exploration, with recent research shedding light on how spaceflight affects our bodies at a fundamental level. Speaking of science that needs further investigation, but interesting nonetheless, A groundbreaking study has found that time spent in space appears to accelerate many of the biological processes we typically associate with aging here on Earth. When astronauts venture beyond our atmosphere, their bodies undergo remarkable changes that mirror what happens during the aging process, but at an accelerated rate. Scientists have discovered that space travel triggers significant shifts in genomic stability and causes our cellular powerhouses, the mitochondria, to function less efficiently, similar to what happens as we age naturally. One of the most striking findings is how spaceflight affects inflammation in the body. The research shows that astronauts experience increased inflammatory responses, much like what we see in elderly populations on Earth. This is particularly concerning when we consider muscle health, as the study revealed patterns of muscle wasting that closely resemble a condition known as sarcopenia, which typically affects older adults. Perhaps most significantly, this is the first comprehensive examination that draws direct parallels between spaceflight and what scientists call biomarkers of frailty. These are essentially biological warning signs that indicate how quickly our bodies are aging and becoming more vulnerable to health issues. The research suggests that time in space might actually induce a frailty-like condition in astronauts, regardless of their age. These findings aren't just important for space exploration. They could have far-reaching implications for healthcare both in space and on Earth. By understanding how spaceflight accelerates these aging processes, scientists might be able to develop new treatments that could help both astronauts and elderly populations. The research team is now advocating for the development of a specialized frailty index to monitor astronaut health during missions, which could become a crucial tool for ensuring the safety of future space explorers. Exciting developments are underway in the satellite servicing industry, as Northrop Grumman's Space Logistics Division prepares for a groundbreaking 2026 launch. They're developing what's called the Mission Robotic Vehicle, or MRV, a sophisticated spacecraft equipped with robotic arms that could revolutionize how we maintain satellites in orbit. These aren't just any robotic arms. They've been specially developed by the U.S. Naval Research Laboratory and have already passed crucial testing phases. The arms will enable the MRV to perform intricate tasks on satellites positioned more than 22,500 miles above Earth in geostationary orbit, where many of our critical communication satellites operate. What makes this particularly interesting is that Space Logistics has already secured its first customers. Both Intelsat and Optus have signed up to have their satellites serviced with what are called mission extension pods. Think of these as space-based jetpacks that can add about 6 years of operational life to satellites that are running low on fuel. This is crucial because roughly 10 satellites in geostationary orbit reach the end of their operational life each year simply because they run out of fuel. The MRV represents a significant advancement over previous satellite servicing vehicles. Unlike its predecessors, it will be capable of performing more sophisticated tasks, including detailed inspections, repairs, and even relocating satellites to different orbits. These capabilities could prove invaluable for both commercial operators and government agencies looking to extend the life of their space assets. The economics of this technology are particularly compelling. The mission extension pods, weighing about 350 kilograms each, offer a more cost-effective solution compared to launching entirely new satellites. By using electric propulsion to reach their target orbits and relying on the MRV for installation, these pods provide a practical way to extend satellite operations without the enormous expense of replacement missions. In a stunning display of science meeting natural wonder, NASA recently conducted a fascinating experiment in the auroral skies over Norway. On November 10th, during a minor geomagnetic storm, 2 rockets launched from the Andøya Space Center carried out what's known as the vorticity experiment, or vortex, creating artificial clouds that danced beneath the shimmering northern lights. The purpose of this experiment was to better understand the complex interactions occurring in a particular region of our atmosphere called the turbopause. This is where the mesosphere meets the thermosphere, about 56 miles up. To study these interactions, the rockets released a compound called trimethyl aluminum, which formed visible swirling patterns in the sky. Local photographer Ivar Sandland captured this remarkable event while on a road trip near Mount Stettin, Norway's national mountain. He initially thought he was witnessing some strange cloud formation, only to later discover he had documented a significant scientific experiment in action. The timing couldn't have been better, as the artificial clouds appeared against a backdrop of vibrant auroral displays. The location of this experiment wasn't chosen by chance. The Andoya Space Center's position near the Arctic Circle makes it an ideal spot for studying geomagnetic activity and auroras. This is because Earth's magnetic field naturally funnels charged particles from the sun toward the poles, creating the perfect natural laboratory for understanding space weather phenomena. These artificial clouds aren't just for show. They serve as visible tracers that help scientists understand how gravity waves behave and interact at this crucial boundary in our atmosphere. This knowledge is vital for improving our understanding of atmospheric dynamics and their influence on our planet's weather and climate systems. While on the subject of unusual sights in our skies, a spectacular fireball lit up the skies over North America earlier this week, treating observers across the U.S. Midwest and parts of Canada to a dazzling celestial show. Unlike the recent Starlink satellite re-entry, this was a genuine visitor from outer space, blazing through our atmosphere early Monday morning at around 6:31 Mountain Time. The meteor created quite a spectacle as it streaked southeast across the morning sky, visible from Alberta and Saskatchewan in Canada, throughout Montana, Idaho, and parts of Washington, Wyoming, and North Dakota. Eyewitnesses described a brilliant green streak that brightened dramatically for several seconds, creating such intense illumination that it briefly lit up the surrounding landscape like early morning. What makes this event particularly noteworthy is that it was captured not only by countless doorbell cameras, dash cams, and cell phones on the ground, but also by sophisticated equipment in space. Two NOAA weather satellites, GOES-16 and GOES-18, detected the fireball using their lightning detection instruments, providing a unique perspective of this cosmic event from above. According to reports submitted to the American Meteor Society, this was an exceptionally bright fireball. One observer in Alberta noted it was among the most spectacular they'd ever witnessed, describing a greenish streak followed by an intense flash with a secondary dimmer flash along the same trail. Another witness in Montana reported that the meteor was so bright it temporarily illuminated their surroundings as if it were mid-morning. These impressive displays occur when small pieces of space debris, known as meteoroids, collide with Earth's atmosphere at extremely high speeds. The friction generated by these collisions with air particles creates intense heat that vaporizes the space rocks, producing the brilliant streaks of light we see as meteors. While most of these visitors from space completely burn up in our atmosphere, they certainly know how to put on a spectacular show on their way out. Next up, NASA's TRACERS mission has just hit a significant milestone with the completion of its twin spacecraft, marking a crucial step forward in our quest to better understand space weather. These satellites, built by Millennium Space Systems, are designed to study a fascinating phenomenon that occurs where the solar wind meets Earth's protective magnetic field. The mission's primary focus is investigating magnetic reconnection, a powerful process that happens when magnetic fields intersect and release enormous amounts of energy. Think of it as a cosmic dance between the sun's magnetic field and Earth's magnetosphere, creating bursts of energy that can affect everything from our power grids to satellite communications. What makes TRACERS particularly innovative is its unique approach using two satellites flying in formation through Earth's polar cusps. These are funnel-shaped regions where our planet's magnetic field opens up over the north and south poles. By having two spacecraft collecting data in tandem, scientists will be able to observe how quickly these magnetic reconnection events evolve and change, giving us unprecedented insights into these complex processes. The completion of both satellites marks the transition from development to the crucial testing phase. Once testing wraps up, they'll be shipped to Vandenberg Space Force Base in California for integration with their launch vehicle. The mission team is working towards a target launch date in early 2025, and they've already passed a critical review that gives them the green light to move forward with final preparations. This mission couldn't come at a more important time. As our society becomes increasingly dependent on satellite technology and power grids, understanding space weather becomes crucial for protecting our infrastructure. These twin spacecraft will serve as our eyes in the sky, helping us better predict and prepare for space weather events that could impact our daily lives. Now we have a fascinating story of galactic survival, which is unfolding right in our cosmic backyard, and the Hubble Space Telescope has given us a front row seat. The Large Magellanic Cloud, one of our nearest galactic neighbors, has apparently just survived what we might call a close brush with the Milky Way, and it's showing us the scars of this encounter. This dwarf galaxy, which appears in our southern sky as an object about 20 times larger than the full moon, seems to be just passing through rather than orbiting our galaxy. Scientists have discovered that this cosmic drive-by has literally stripped away most of the gas surrounding the LMC, leaving it with an unusually small halo, just 50,000 light-years across, which is tiny compared to similar galaxies. But here's what makes this story remarkable. The LMC has emerged as a true survivor. Despite losing most of its gaseous halo to our galaxy's gravitational influence, it's managed to hold on to just enough gas to keep forming new stars. This resilience comes down to its size. At about 10% of the Milky Way's mass, it's actually quite hefty for a dwarf galaxy. The process that stripped away most of the LMC's gas is called ram pressure stripping. Imagine our galaxy acting like a giant hairdryer, blowing away the LMC's gas as it passes through. The intense pressure has pushed back most of the original halo, leaving just a small, stubborn remnant that refuses to be blown away. We know all this thanks to Hubble's unique ability to observe ultraviolet light and some clever use of background quasars as cosmic flashlights. The telescope analyzed light from 28 distant quasars passing through the LMC's halo, giving scientists their first real measurement of what's left of this cosmic survivor's gaseous envelope. Well, that brings us to the end of another fascinating episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest discoveries in space and astronomy. From Einstein's theories being challenged to spectacular fireballs lighting up North American skies, it's been quite a show today. If you're hungry for more space news, I've got great news for you. You can catch up on all the latest developments in space and astronomy at our website, astronomydaily.io. There you'll find our constantly updating newsfeed, all our past episodes, and you can sign up for our free daily newsletter to never miss a beat in space exploration. And hey, let's stay connected. You can find us across all major social media platforms. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. Until next time, keep looking up and stay curious about our incredible universe.